So very good morning to all of you. In this lecture I am just going to solve the few examples to understand the concept of Hamiltonian dynamics, and in this lecture especially I will discuss that for a given Lagrangian I am not going to construct the Hamiltonian, because in earlier lecture I have already construct the Lagrangian. So if we have a profile of Lagrangian, then how to obtain the Hamiltonian expression and corresponding Hamilton's equation of motion. So suppose if we have a example, or if we have an expression of Lagrangian which is L equal to, if the Lagrangian of system, if the Lagrangian of system is given as, which is L equal to a x dot square by 4 plus by dot square by 4 minus k of xy. So what is h? Then what is h means what is Hamiltonian expression. So what is our objective, or what is our aim in this lecture is to obtain the expression of Hamiltonian for a given Lagrangian. So how to obtain? Because we know that our Hamiltonian is simply function of generalized coordinate, generalized momenta and time, while our Lagrangian is simply function of generalized coordinate, generalized velocity and time. So anyhow, in this L expression we have a generalized velocity. So anyhow we have to replace, we will replace this generalized velocity by generalized momenta. So replace qk dot by pk using, and how to replace? Again we have very important tool or very important concept, that is concept of generalized momenta. So using concept of generalized momenta. So what is generalized momenta concept? This is simply del L upon del qk dot is simply pk. So this is the concept of, means differentiating our Lagrangian with respect to generalized velocity, we will have pk. And what is our qk? In this Lagrangian expression we can see our qk is generalized coordinate, which is x and y. So this qk is basically x and y. So we have two different generalized coordinates. So what is our, so generalized momenta for x coordinate. So if we, this is for x, what is our generalized velocity? This is del L by del x dot, which is px, and what is del L by del x dot? Simply twice ax dot by 4. So this is twice ax dot by 4. This implies that x dot is simply 2 px by a, and for y coordinate our generalized momenta is del L by del y, which is py. So what is del L by del y? Differentiating this L partially with respect to y dot, so we have 2y dot by by 4, which is 2y dot b by 4. Again 2 will cancel out, and what we have, this y dot is simply 2 py by b. So this is And what is the relation? How to convert our L into H? So we have a relation between L and H. And what is that relation? That relation is simply H of QK PK T is equal to summation of K PK QK dot minus L, which is function of Q dot QK dot and T. This is very standard relation basically. So with the help of this relation, we can convert our L into H and vice versa. So with the help of this relation, we can obtain expression of H for given L, and converse is also possible, and vice versa is also possible. So we can find out the H for a given L, and we can also find out the L for given H. So in this case, we will find the expression of H for given L. What is your PKQP? This K is a running index. So in this case, our K is X and Y. In this case, we have two variables. So this K is a running index. So in this case, we can write it as, this is H, QK, PK and T, which is, this PK is Px x dot plus, because this is summation, and we can, when we will open this summation, so we have different expression. So this is Px x dot plus Py y dot. If our Lagrangian, because our L is having only two generalized, if there is a z term, then we can write also P z dot, but fortunately we have only two generalized coordinates. So, and this is, what is our L? L is simply ax dot square by 4 plus by dot square by 4 minus k of xy. So this is the final expression of H. But our H is only, mind it, our H is only function of generalized coordinate, generalized momenta and time. But in this case, our H is a function of generalized momenta, generalized velocity. So anyhow, we have to replace this generalized velocity by using the concept of generalized momenta. So from these two equations, let's say this is equation 1, this is equation, this is 2, and this is equation 3. So from 1 and 3, substituting the value of x dot y dot from 1 into 3. So what we have? So now putting the value of x dot y dot from equation 1 in 3, or using concept of generalized momenta, we can replace our generalized velocity by generalized momenta. So in this case, our, what is our H is simply Px x dot. So x dot is 2px by a. So this is 2px by a. Similarly, Py y dot. So y dot is 2py by b minus a by 4 x dot square. A by 4 x dot square means 4 px square by a square plus b by 4 y dot square. B by 4 y dot square. So y dot square is 4 py square by b square. 4 py square by b square minus of kx y. Now see, now our Hamiltonian is only in terms of generalized coordinate and generalized momenta. Now rearranging this expression. So what we have, this is simply 2px by a 2py square by B minus Px square by A minus Py. This 4 will cancel out, BB will cancel out, we have plus this is simply K of xy. Now again rearranging this expression. So this is 2 twice of Px minus Px is simply Px square by A plus Py square by B plus K of xy. So now you can see that this is Qk, Pk, and there is no T term. So this Hamiltonian absent, there is no T term. So this is HQK Pk, which is simply Px square by A plus Py square by B plus Kxy. So this is the way to find out the expression of Hamiltonian for a given Lagrangian. So using the concept of, we have very good concept, that is concept of generalized momenta. With the help of that concept we can simply convert, and rest is mathematics. Now if we have an expression of Hamiltonian, we can set up a Hamilton's equation. We can also set up a Hamilton's equation. So Hamilton's equation of motion, which is del H upon, we have three different sets, del H upon del Qk, which is minus Pk dot, del H upon del Pk, which is Qk dot, and if there is a time term, so del H by del T is minus of del L by del. These are three different sets of equation known as Hamilton's equation. So our Qk is Qx, x and y, and Pk is Px and Py. So corresponding we have four different sets of Hamilton's equation. So we have, and there is no time term, so we have no del H by del T term. So we have four sets of equations, which is, what is our del H upon del x, which is minus Px dot, and what is del H upon del x? It means differentiating h partially with respect to x and treating rest of the variable treated as a constant. So del H by del x is, this will 0 and this will Ky. So we have Ky. Similarly, what is del H upon del Px, which is x dot, del H upon del Pk is Qk dot, Qk is x, because we are talking about x. So differentiating partially with respect to Px. So if we will differentiate, this will 0, this will 0, this will twice of Px by A. So we will have simply twice of Px by A. And similarly, because we have two different generalized coordinate, one in x and another in y. So differentiating this partially with respect to y. So del H upon del y, which is minus Py dot, and what is del H upon del y? Del H upon del y is differentiating partially h with respect to y. So with respect to y we have only this term is treated as constant, this will 1, so we have K of x. And what is del H upon del Py, which is simply y dot, again differentiating this h partially with respect to Py. So we have only one Py term, so which is 2 Py by b, 2 Py by b. And what is del H upon del T, which is 0, which implies that h is constant, and this system is known as conservative system. If there is no time term, so h is a constant of motion, which means we can express our h or Hamiltonian represent the total energy of system, which is T plus V, which is T plus V, which is constant. So this is the way to find out the Hamiltonian expression for a given L, and if we have an expression of L, then we can easily find out the Hamilton, or we can easily set up the equations, Hamilton's equation, which is 4 sets of equation. So corresponding to one Lagrangian expression, we have 2n plus 1 different sets of Hamilton's equation. But if there is no time term, if the Lagrangian is time independent, here our Lagrangian is time independent, then we have only 2n sets of equation. 2n sets of equation. It means for one Lagrangian we have, for one generalized coordinate we have 2 sets of Hamilton's equation. For 2 generalized coordinate, because in this case we have 2 generalized coordinates, so that is why we have 4 sets of Hamilton's equations. So there are several ways by which there are a lot of objective questions can be formulated, that how many Hamilton's equation corresponding to this Lagrangian, how many sets of Hamilton's equation, what is the Hamilton's equation, what is the generalized coordinate, what is the degree of freedom, what is this system is constant of motion, or is this system is conservative system. So yes, because H is constant, so this system is a conservative system, and for this system our H is T plus V. So it's all about these examples. Thank you.